Today we are going to understand all of geology in just 5 charts. Let's dive in. Hey guys, what's up? If you're new here, welcome to the channel. My name is Reese, and I used to teach tech ethics at MIT, but these days I'm mostly just an information sponge. And so over the past decade, I've read hundreds of books and done hundreds of interviews on my podcast to try to understand how the world works. I've made these 20,000 note cards, and I study them all the time to try to get fluent, kind of like Duolingo, but in the language of reality. And I want to share my fluency with you. And I do that through this How Everything Evolved YouTube series, where we look at everything from the Big Bang through AI. And thus far, we've looked at from the Big Bang through the start of Earth, how we got the atoms and the elements. But what we're going to look at today is how the heck does Earth work? How does geology work? And so we're going to look at 5 different graphs to understand how geology works. Okay, here's the first graph. It's the rock cycle. The rock cycle is amazing. It is you can see here that there's igneous rock, metamorphic rock, and sedimentary rock. Igneous rock is the main rock that comes out of the ground. It's how all rock starts. And then eventually that rock can become sedimentary rock by turning into sediments, and then those sediments getting compacted down into sedimentary rock. You could go from igneous rock or sedimentary rock to metamorphic rock by doing that weird heat and pressure thing where you get the little wavy patterns that we see in metamorphic rock like schist or gneiss. And this is pretty much how the rock cycle works. Igneous rock comes out of the ground, turns into sedimentary rock or turns into metamorphic rock, and then eventually all that stuff turns back into magma and comes back out again. It's kind of simple. Now, here's the second graph. Igneous rock can be broken down to these categories. Initially, this looks confusing, but it's actually pretty simple. There are only 2 important things on this graph. One of them is the granite column, and one of them is the basalt column. And so granite is on the left. What this means is that it is more felsic, which means that it has more silicon and oxygen. It has more sand. That's why you see the quartz here. These feldspars are just a different name for kind of sandy silicates. And so you have granite, and granite is what most of the crust is made out of. It's what most of the continental crust is made out of, 75% granite. And then you have on the other side something like basalt. Basalt is more mafic. And by the way, felsic stands for feldspar, while mafic stands for magnesium and ferric. And that just means it's more irony. And so deep in the earth, it's much more iron and magnesium. And then at the top, it's much more, silicon and oxygen, because those are lighter elements, and so they rise to the top. But something like a mafic thing like basalt, if you imagine Hawaii, that's a lot of basalt coming out of the ground. It's more mafic, it's more ironous. And so those are the only 2 things you need to care about are granite on the left and basalt on the right. Okay, so this graph talks about all these kinds of minerals, quartz and feldspar and pyroxenes and olivines and amphiboles. What are those things? Well, that gets to our third graph here. And so the way that I think about this is if you imagine all the different ways to be a mineral in the world, almost all of them are silicate. They're things that have silicon and oxygen, SiO2, as part of their crystal structure. And so at the bottom here are ones that are a higher percentage of silicates. So something like quartz here, it's a 3-dimensional network. That's why it's shiny, that's why it's clear, and it's just pure SiO2 or SiO4 really. And then as you go further up, something like a feldspar has a little bit of potassium or a little bit of calcium, a little bit of sodium, but it's still this 3-dimensional network. That's one of the ways that it can be stable. As you go further up, you can see these sheets. So something like a mica, these are all micas that are SiO2, they're sand, but they have a little bit of other things with them, but in a sheet pattern instead of in a 3-dimensional pattern. And so up here you have these chains, which are, like amphiboles and pyroxenes, and those are just, a chain is just another way to be a mineral. You have your silicates that have magnesium and iron around it, and then at the very, very top, you have these olivines, which are the ones with the most amount of magnesium, the most amount of iron, the least amount of silicate. And so that's why they're these independent tetrahedrons, because there's not enough down here. It's all silicon, and so they're connected into this mineral pattern. But up top with an olivine, they're all independent from each other because there's just not that much silicon left. And so you get these small groups of silicon oxide. Okay, here's the 4th graph. When we think about geology, what we've been talking about thus far is all about rocks. We think about solids, and that's actually just one of the spheres on Earth, one of the geospheres. That's just the lithosphere. That's just the crust and the mountains and all of the solid things on Earth. Because there's also the hydrosphere, all the water, and all the atmosphere on Earth, all the air, and then there's the cryosphere, all of the ice. And so when you think about Earth and you think about the geospheres, don't just think about the lithosphere, think about all four spheres combined. And you can think about those geospheres interacting with the biosphere as a whole. And so I like to think of it as the elements making their way through the geospheres and also the biosphere. So the carbon cycle, the oxygen cycle, the nitrogen cycle, these are all elements that are moving, the phosphorus cycle, the sulfur cycle, they're all moving through the geospheres and moving through the biospheres. So something like carbon is put out into the atmosphere by volcanoes and by humans. A lot of CO2 gets out there. That CO2 might go into the water. It might go from the atmosphere to the hydrosphere, or maybe it'll have enhanced weathering. It'll go into the lithosphere, and then maybe some creatures like, some plants might take it up and breathe in CO2. So you can imagine carbon moving through these cycles over time. And the fifth graph here is on global warming and climate change. And so we can use our understanding of those Earth systems and those biospheres and geospheres to say, how are they doing today? And you can see here, it's like, oh, here's all these greenhouse gases that go into the atmosphere. They turn into ocean acidification. That's the hydrosphere. You can see there's all these feedback loops where, if a bunch of the permafrost thaws, then you get a bunch of methane that goes out there. And so then it gets hotter. Then you can also look at, what about these effects on the environment, all the biospheres? And so that are things like glacial retreat and ice sheet melt. So the cryosphere is all going to go away. And then what happens for sea level rise? And then, of course, then there's the impacts on human health. And you get, cities that flood, or humans have to migrate and crops fail because it's too hot or what have you. So yeah, I think this is a great way. Once you start to understand the geospheres, you can start to understand climate change better. So I hope those 5 graphs help you understand geology better, both how rocks work and also the geospheres as a whole, and especially how they're doing with climate change today. Thank you as always for listening. Thank you to the supporters of Root for supporting this educational content. If you want to learn more about how Earth came to be, check out previous episodes, how atoms came to be, how the elements came to be, or if you're excited to learn about the future and what's going to happen on Earth, how life forms, feel free to subscribe for more. Thanks.